After we're going to solve today this revision sheet for the daily exam. Start from exercise number 2. What is the objective of this exercise? It's to compare the real numbers a, radical a square, 1 over a, and relative to 1. I recall the rules here. The first rule indicates if the number is greater than 1, if a is greater than 1, then a square is stronger than a, stronger than radical a, stronger than 1, and stronger, we mean by stronger, greater than 1 over a. Otherwise, if a is a positive number less than 1, then a square is weaker than a, weaker than radical a, weaker than 1, weaker than 1 over a. Consequently, going to our exercise, the first part A, we are comparing two real numbers, which are a, as you see, and a square. A and a square, but a, which is the radical 3 minus 1, approximately 0.7, this is a number, positive number less than 1. Then this obeys the rule number 2, which means that a square is less than a. So we say that radical 3 minus 1 square is less than radical 3 minus 1. Okay, going to part B now. Also, we are comparing here a certain number a to radical a. So we are comparing a and radical a, where a is radical 7 minus 2. Radical 7 minus 2 also is a number less than 1. Okay, remember, it is a positive number less than 1. Okay, so it obeys the second rule. In the second rule, which is greater, a or radical a is greater. So the radical of radical 7 minus 2 is less than radical 7 minus 2. In part C, as you see, ladies and gentlemen, we have a square and radical a. Which is stronger, a square, radical a, or a square, radical a? Okay, it depends on a, whether it's greater than 1 or less than 1. In fact, a here is pi minus 1, and pi minus 1 is a number. So a, we are comparing a square and radical a, but a is pi minus 1, approximately 2.14. This means a is greater than 1. And so, consequently, if it's greater than 1, in the first rule, we say a square is greater than radical a, or radical a is less than a square. So pi minus 1 is less than pi minus 1 square. Now we go to exercise number 3. Simply in exercise number 3, because we have radicals in both x and y, we have to square them both and see what happens. If we square y easily, we remove the bigger radical sign, we get 7 minus 2 radical 10. If we square x, here we have to square it according to the remarkable identity a minus b squared, which gives a squared minus 2ab plus b squared. A squared minus 2ab plus b squared, which yields to 7 minus 2 radical 10. As you see, if you compare the answers, this means that x squared is equal to y squared. But this does not mean x equal to y necessarily. This means x equal to y or x equals to minus y. But if you go back to x and y is positive because y is made up of a radical sign. So y is positive. However, x is negative. Why? Because x is difference of two numbers in which the first is less than the second. So this means that x negative. If x negative and y positive, then x equal y is rejected because a negative number cannot be equal to positive number. This means this one is accepted. Finally, we say x equals to minus y. Let's go to exercise number 4. Here we have to frame some real numbers. Okay, given, as you see, 3 less than or equal to x less than or equal to 7 and y is framed between 2 and 8, we have to frame x plus y. Easily, when we want to frame x plus y, we add the frames of the other two. So if 3 less than x less than 7, 2 less than y less than 8, now we add them and we easily get x plus y is framed between 15 and 5. Now, what about x minus y? We cannot subtract frames at all. So what do we do in this case? We add x to the opposite of y. So we bring x and the opposite of y, which is between what and what? Minus 8 from the left and minus 2 from the right. And then we add instead of subtracting. So we get 3 minus 8, x minus y, and 7 plus minus 2, which is 5. This is the difference x minus y. What about finding x times y? Simply, we write x, we write y, and directly we multiply them, no problem. 6. Okay, let's go to the black color now. 6 is less than or equal to xy, less than or equal to 7 times 8, which is 56. Now, what about x over y? We cannot divide, just like the subtraction. We cannot divide frames. Instead, we multiply. Look, my dear, x over y means x times 1 over y. So we have to multiply x by the reciprocal of y. Now, what is the frame of x? X is frame between 3 and 7. What is the reciprocal of 1? The frame of the reciprocal of y? It's between 1 over 8 from the left and 1 over 2 from the right. Now we multiply the results so that we get 3 times 1 over 8, or 3 over 8, in other words, x times 1 over 5, y, which is x over y, 7 times 1 over 2, which is 7 over 2, end of the frame of this one. Finally, or before the final one, x squared plus y squared. X squared, as both are positive frames, x squared is frame between 3 square and 7 square. Y square also between 2 square and 8 square. Now we add them. What do we get? 13 is less than x squared plus y squared less than 113. Okay, and finally, go to x plus y. We have the frame of x plus y found first before, which is between 5 and 15. So simply we can frame its reciprocal between 1 over 15 from the lower side and 1 over 5 from the upper one. This is the end of this exercise. Now move to number 5. It's very important objective, which indicates if we want to prove a number greater than the other, we subtract them and the difference must be positive. However, if we want to prove a number less than the other, we subtract them and the difference should be negative. Now here, we want to prove that the left-hand side is less than the right-hand side. What do? We subtract them as we said before. For example, 24x squared plus 10x over x squared plus 1. Simply, I repeat again, to compare two real numbers a and b, we subtract them. If this difference is positive, this means a is greater than b. Same sign. If this difference is negative, then this means a less than b. Okay? So now we are going to subtract this side from this side. Now, how to subtract this? This is algebraic expression. To subtract it, we are going to take common denominator. How? Multiply this numerator, or this fraction, in fact, by x squared plus 1. What do we get in this case? We get 24x squared plus 10x over x squared plus 1 minus 25x squared plus 25 over x squared plus 1. Continue. We get 24x squared plus 10x minus 25x squared. Don't forget to multiply this minus. Okay, over x squared plus 1. We should write the equal along with the dash. Now what do we get? Minus x squared plus 10x minus 25 divided by x squared plus 1. As you see the numerator, ladies and gentlemen, you have to take minus in common. You get x squared minus 10x plus 25 over x squared plus 1. And finally, this numerator, that is x squared minus 10x plus 25. This one is a remarkable identity. This is a perfect square. This is x minus 5 square multiplied by minus outside. So we get minus x minus 5 squared over x squared plus 1. And this answer is absolutely negative, less than or equal to 0. Proved. That's what we want to prove. When we subtract them, we get less than 0. This means the first part was greater than the second part. So I repeat, we reached this answer, x minus 5 squared over x squared plus 1. Now, this is a positive quantity always, sum of two positive numbers. This is a square, and the square is always greater than or equal to 0. Multiplied by minus, this means the answer is less than or equal to 0. When we subtracted the first two, a minus b, and we get less than or equal to 0, this means that a is less than or equal to b. And therefore, this means that the first part was less than the second part. Proved. We move now to this exercise number 6. Now we have two sets, A and B. We have to write them in the form of an interval. In the first part A, we have to solve the inequality. 2x minus 1 in absolute less than 9. This means that 2x minus 1 is bounded between minus 9 and 9. Now to solve this inequality, we have to add al-jabr wal-muqabala. Do you remember? We have to add 1 to all the inequality to get rid of minus 1 here. So we get minus 8, 2x, 10. Then we divide by 2. So that what do we get now? We get minus 4 less than x less than 5. And consequently here we get the set A. A is the interval, all real numbers from minus 4 to 5. And since there is no equal in the inequality signs, so we open the intervals. Move now to set B. In set B, we have also an equality containing absolute value, but this time is greater than a number, positive number. So we write it like this: A greater than B, or A less than minus B. So this is 2x greater than 4, x greater than 2, 2x less than minus 10, x less than minus 5. Now, how do we write this as an interval? Okay, if you don't know, then we go to a number line. Here we have minus infinity, here we have plus infinity, here we get minus 5, here we get 2. 2 is greater than minus 5. We have x greater than 2 and x less than minus 5. So as an interval, B is written like this. This is the set from minus infinity to minus 5, open intervals, union from 2 to plus infinity. Now we want to find the intersection, the union, in addition to A bar and B bar. Let's go. So A is from minus 4 to 5. B is minus infinity, negative 5, union 2 to plus infinity. To find the intersection and the union, and also A bar and B bar, we need to represent these on a number line. Suppose this is a number line from minus infinity to plus infinity. I represent A using the orange color, for example. If this is -4 and this is 5, then A is between -4 and 5. All of this is the set A. Now, where's the set B? B is the set from -5. Okay, I'll use another color. Let's say the green one. -5 comes here. And 2 comes here. Okay. B, the set of real numbers less than -5 and greater than 2. Okay, so this is B, all of this region. Now I am going to search for the intersection part to get A intersection B. A intersection B represents the common part. The common part, as you see, is between 2 and 5. Okay, what about A union B? What do we mean by A union B? A union B, which we read it A or B, this means any values found in A, either in A or in B or in both. So all the colored regions, which are from -infinity to -5, union, this is this one colored, and also all of these, that is from -4 to plus infinity. Now, we are going to find A bar and B bar. I represent A alone and B alone and search for A bar and B bar. Okay. Concerning A, it's all real numbers between -4 and 5, excluding -4 and 5. So this is A. And what about B? B, all real numbers less than -5 and greater than 2. Okay. The uncolored region in the first one is A. So the uncolored region is here and here. It's from -infinity to -4. And since -4 were open in A, we close it now because A bar is the opposite of A. And also the second part is from 5 to plus infinity. However, concerning B, the non-colored and non-shaded part is between -5 and 2. Also for the same reason, it's closed. End of this exercise now. And finally,